Hello and welcome to section 10.3, which is on areas of regular polygons. So a few things we need to know first. The radius of a regular polygon is the distance from the center of that polygon to a vertex. The apothem is the perpendicular distance from the center of the polygon to a side. So for my example here, I have part of a regular octagon drawn. It has the radii and an apothem drawn. What is the measure of each numbered angle? And so the first thing we need to realize is that it's going to have 8 central angles because there are 8 sides. So all of these central angles added together is going to equal 360. And so we know that angle 1 is from vertex to vertex. And so if I take 360 and divide it by 8, I get 45. So angle 1 is going to equal the 45 degrees that the central angle should equal. Angle 2, you can see, is only going to be half of that because it's drawn perpendicular. Angle 2 is just that little chunk in there. So it's going to be half of the 45, so it's going to be 22 and a half. And then I also want to know angle 3. I need to add up. You know that this piece right here is going to be 90 because that's perpendicular. So if you add up your 90 and your 22 and a half that you have there, you get 112.5. And then you subtract that from 180. And you get 67.5 degrees then for angle 3. Area of a regular polygon is 1/2 A times P. A is the apothem, P is the perimeter. So if I want to find the area of the regular polygon with the given apothem and sides, and the one that I've given you here for an example is a pentagon, so that keep in mind that is a 5-sided figure. So if I know that the apothem is 24.3 and the sides are all 35.3, the first thing I need to do is take 35.3 times 5 to find my perimeter for the formula. So 176.5. So if I plug that into my formula, I have 1/2 of the apothem, which is 24.3, times my perimeter, which is 176.5, and then I just need to do the work. So half of 24.3 is 12.15, and then I just need to take that times 176.5, and I should have my answer. So 2144.475 square centimeters. It didn't say it around, so I just went ahead and left it. And then the last example I have for you, the side of a regular hexagon is 16 feet. What is the area of the hexagon to the nearest square foot? This one is going to be a little more difficult, but if we go from the middle there, that would be a radii, and then if we go straight down so that it's a right angle, this measurement right here, this length, is going to be called the apothem. And so we know that from here halfway across right there is going to be 8. And something else that we know is the central angles of a hexagon is going to be 360 divided by 6 because there's 6 of them. So this little chunk right here is 60, and we know that this is 90. So that's a 30, 60, 90 triangle, and because that's a special right triangle, there's something we know about this side right here. It has to be the shorter leg, which is this one, times the square root 3. So then basically we know that the apothem is 8 square root 3. So now we can use that in our formula. Our formula is still A equals 1/2 AP, and we have half. Our apothem is 8 cube root 3, and our perimeter will be 16 times the 6 sides, so 96. Plug that in, and then I could do half of 96 is 48. And if you work this all out, if you figured out what 8 times cube root 3 is and took it times 96, you would get 665 square feet approximately. It says nearest square foot, so rounding it, that's what it would be. So you can use the apothem and the perimeter to find the area of regular polygons, something we've never really done before. So bring that knowledge with you, and we will talk about it more the next time I see you. Have a good night.